Hello, I will try to explain how our CNC works. Here we see our control panel with all the operating buttons. First we see the emergency restore and the buttons that controls the position of the bending roll. The slow button to reduce the speed of positioning of the bending rolls. The buttons that starts the hydraulic unit that position the fourth roll, the emergency, the stop cycle button, the button that allows to select manual, semi-automatic and automatic mode, and the other buttons that command rotation and positioning of the rolls. As you can see, there is also a USB port directly on the control panel. Inside the control panel, you see that there are some possibilities to connect external sources or to connect the machine to the LAN. Here we see the axis display. We see the program that is currently running and the position of the X, Z and Y axis. Moreover, we can see the speed setting for the machine. If we check the Y position, now I'm moving manually the bending roll and you see how the position is changing. In semi-automatic mode, the machine starts from the actual position of the axis and moves directly to a fixed position. I input some values. As you can see, I input the values of the three axes and the speed of rotation of the rolls. That is in percentage. Then I set this position and pushing the start button, the control moves all the three axes simultaneously to the set position. If we see what happens on the machine, here is what happens. Now we check how to characterize a profile. The first thing we have to do is to define a pinch position. The pinch position is the position where the profile is locked in between the rolls but is not bent. Here we have a look at the machine. As you can see, this is the pinch position. Profile locked in between the rolls but not bent. The second thing we have to do is to make two bending trials. We move up a bending roll and we roll a bit the profile, and then we check which radius we obtained. Then we make a second trial with the second position of the bending rolls and we check again what is the radius obtained. From these two values we are able, the machine, is able to understand what is the deformability of the material and to calculate for a certain radius what will be the position of the bending roll. At the end, when we characterize a profile, we can save it and store it in the machine. We see once again what happened on the machine when we want to characterize the profile. We go up with the bending roll and we roll a certain length. This will be the first radius. Then we move up again a little bit, we will see the radius is tighter and we have two different radii. We measure the radii. Here I'm using the instrument available. I'm checking also the tighter radius, and those are the two values that I have to write in the profile characterization. Now we will see how to program. First thing we have to do is to choose the profile we want to work with. This profile is a profile we already characterized. As you can see, the pinch position is already loaded once we choose the profile. Then we define the unload position, that is the position the rolls will reach at the end of the program to take out of the piece of the machine. We define the first step of the program. In here I'm inserting a straight line. We choose the length in millimeters and the speed of rotation. Then, for example, we can insert a curve, and we can insert it as radius length, radius angle, or rise and chord. In here I choose radius and length. I put the radius in millimeters, the length in millimeters, and also the speed of rotation. In here we see what will be the radius and the length of the arc. We have another solution to show what are the position of the bending rolls that will lead to such result. As you can see, the first step, the position of the two axes is equal to the pinching position. The second one axis goes up to create the curve. On our control, there is also the possibility to import a DXF file instead of building up the program in this way. Now we will check how a program looks like. I loaded it, and as you can see, we have the program name that we decided before, the profile we will use for such program, and the steps of the program, that in this case are 3. Now we will check another characteristics of our CNC. We have the possibility to perform diagnostics. In the diagnostic screen, we see which are the components that are working in a good way and if there is any error on the machine. On the bottom of the screen you see red lights are off. It means machine is working properly. Now we see the parameters screen. In the parameters screen we have the possibility to see all the settings of the machine, which are the profiles we already stored and the programs we already stored. Then we have the possibility to choose the language of the interface, to backup data and to restore data. Two additional characteristics of our machine are the proximity detector that we see in this video. It's an optical sensor that allows the machine to define what is the starting position for a program. Then we have the fourth roll. The fourth roll is a polyurethane roll kept pneumatically in contact against the profile that allows to refer in a correct way the position of the profile in between the rolls. Now we will see how the machine works when it's correctly programmed. In this case, we are bending a flat bar at a multiple radius curve. This is the first step of the program. As you can see, we have a certain radius and a certain length for the curve. Now the machine will start to move up a bit the bending roll, and we see that the radius is changing. One important thing is that our CNC allows to control simultaneously the variation of positioning of the rolls and speed of rotation. That is an important factor that allows you to control in the best way the geometry and the transition region between two different curves. As you can see, the machine is continuing to change the bending radius, and with this possibility we are able to produce the most complicated geometries. Now we are at the end, so thank you for your kind attention.